Hello, this is FlippedHarber for Algebra 2. In this video we're going to talk about some properties of logarithms. Now our objectives for this lesson are to use properties of logarithms to simplify logarithmic expressions. We also want to take a look at something referred to as the log base change formula. The outline for this video will talk about the product property of logarithms, then the quotient property, the power property. We'll take a look at something called the exponent property of logarithms, and then we'll end by talking about the change of base formula. So the first thing that we see here is the product property of logarithms. Now the product property of logarithms lets us separate a single logarithm out into two logarithms that are added together, or vice versa. This obviously works both ways. If we have two logarithms both with the same log base, notice that we have the same log base on both of these logarithms, then we can combine them to a single logarithm where notice that they are multiplied together. So please make note of that when these two logarithms are added together, we use their product in the single logarithm. And again, they have the same log base. That's also very important. So let's take a look at an example. If I have the log base 4 of 5 plus the log base 4, that's important, they have the same base of, let's say 6, I can write this as a single logarithm where it is the log base 4, has to be the same log base, of 5 times 6, which would be 30. Okay, pretty simple way to apply this product property of logarithms. Now, similarly, the quotient property says that if we have a logarithm of a fraction, we can split that into two logarithms, or vice versa, if we have two logarithms that are subtracted, again, that have the same log base, I can write it as a single logarithm where they are divided. Now notice, please, that the first value goes on top, and then what's being subtracted goes on bottom. So again, looking at a simple example of this, if we take the log base, let's say 6 of 3/5, I can separate this out if I want to into the log base 6 of 3 minus the log base 6 of 5. So again, a nice simple example of a pretty handy property actually. We use this a lot in calculus. Maybe you're not going to go on to calculus, but it's going to be pretty handy for this section at least. Now the power property of logarithms, this is probably the most important property of logarithms. This is really what logarithms were invented for, is dealing with powers. So this is a really super powerful property of logarithms that we can take this exponent right here and move it down in front of the logarithm. Again, this is what logarithms were invented for, is to deal with those powers. So this is really handy when the power is our variable and we're trying to solve for that variable. So to look at an example, if I have the log base 2 of 10 cubed, I can quite simply bring that 3 down in front, and now I have 3 times the log base 2 of 10. Now I want to go ahead, just to show you what it looks like a little bit, I want to go ahead and I'm going to apply that product property of logarithms. I've got my 3 here, and I'm just going to take a look at this 10. Now I know that 10 can be broken up a lot of different ways, but one way I can break up this 10 is as 2 times 5. So I can write it as a product inside the logarithm which means that I can break it up into two separate logarithms. Now the reason I show you this is I really want to drive home the idea that this 3 is going to multiply both of those logarithms. So I'll have the log base 2 of 2 plus the log base 2 of 5. Well, I kind of did this on purpose. The log base 2 of 2 is 1. So that's 3 times 1, which is 3, plus 3 log base 2 of 5. So I just wanted to show you that that 3, that what used to be a power is now a product, a multiple in front, needs to be distributed if you start to apply other properties of logarithms. Alright, so moving right along, this gets into how we're going to be using logarithms in the future. The exponent property of logarithms just basically says that logarithms are the inverse of exponents. So if I take the log base a of a to some power b, now what's really important here is that the base of the logarithm matches the base on what's operating inside. So the log base a of a. Those can cancel and we're just left with b. So the log base 3 of 3 cubed, or let's make it 3 to the 4th so they're not all 3's. Well, the log base 3 is going to cancel with the 3 and just leave the 4. So logarithms are great for dealing with exponents. Now another way that they cancel is if we see a log in the power. Now again, we see some matching right here with the a's. So the number that the logarithm is an exponent on needs to match the log base. So if we have 2 raised to the log base 2 of 3, well, the 2 and the log base 2 are going to cancel, and we're just going to have 3. Now, let's say, for example, that you have a log base that doesn't match the number. So if I try to do a 2 raised to a log base 3 of 5, for example, there's not really anything I can do with that because the 2 does not match the 3. So I'm stuck with that one. It doesn't really get any simpler for me. Now, this equation, the change of base formula, is actually very, very, very useful because it lets us change the base on logarithms from a number that we don't necessarily want to work with into a number that we do want to work with. Now, if you look on your calculator can do two types of logarithms. It can do a log base 10, what's referred to as the common logarithm, and it can do a log base e, what's referred to as a natural logarithm. Now, if you were asked what is the log base 3 of 4, now the 3 and the 4 don't really get along well. You know, if I had asked you what's the log base 3 of 9, well, that works out nicely, but the log base 3 of 4 does not work out nicely. It's actually an irrational number. So it's something we would want to plug into our calculator, but our calculator doesn't do log base 3's. Well, what we can do is change it to a log base that our calculator would do. So this would equal the log base 10, or the common log, of 4 divided by the log base 10 of 3. Now what's important here is that the log bases in this fraction are the same. They're both log base 10. Now there's no rule that says it has to be log base 10. It could be log base 5, it could be log base 82, just as long as it's the same. Again, it makes sense to use a log base 10 because our calculators can do that. So we could actually plug this into our calculator and get a decimal approximation. Similarly, if I had something like the log base 6 of 3, Now you might think, well, log base 6 of 3, maybe that works out nice. 6 and 3 have a nice relationship, but the log base 6 of 3 does not work out nice. So if we wanted to plug this into our calculator, we would want to change it to a base that our calculator can do. Well, instead of a common logarithm, a log base 10, we could use a natural logarithm. So we could change this into the natural log of 3 divided by the natural log of 6. Now, I always try to remember this, that whatever logarithm I'm using, if I'm taking a common logarithm, a log base 10, or a natural logarithm, or any logarithm for that matter, I'm always putting the big number on top, right there, and I'm putting the little number on the bottom. So I always try to keep it straight by remembering that those numbers kind of stay in order. The 3 is above the 6 when it's log base 6 of 3. Well, the 3 stays above the 6 in the fraction also. Okay, well, that's it. This video is all over. It's time for you to try some of this on your own. I'll see you in class, and I'll see you online.